Hi there, Algebra 2, 5.1, polynomial functions. To classify polynomials, to graph polynomial functions, and describe end behaviors. A monomial is a real number, a variable, or a product of real numbers, and one or more variables with whole number exponents. Degree of a monomial is one variable is the exponent of the variables. Polynomial is a monomial or a sum of monomials. Degree of a polynomial is the greatest degree among its monomials terms. Polynomial function is a function such as a quadratic, a cubic, a quartic, and so on, involving only non-negative integer powers of x. Turning point is a point at which the derivative changes sign. Endpoints of a function f of x describes the behavior of the graph of the functions at the ends of the x-axis. Alright, standard form of polynomial function. The standard form of a polynomial function arranges the terms by degrees in descending numerical order. So, obviously you're going to have the highest exponent first, then the next highest, and the next, and the next, all the way down to a constant, if there is one. Where x is a non, not too much importance out of that. Alright. Ooh, I didn't realize I forgot to erase. Yeah. So, you have this first one is to the third power. That is going to be cubic. That is when you're describing it based on the number term. The second one, if you got rid of the cubic, would be quartic. It'd be to the second. If you got rid of this one, you would be down to just 5x minus 2, which would be in a linear based off the degree. And then if it's just with a constant, it is a constant term, obviously. Yeah. Now, we have a graph we have to fill out here. Alright, degree. The first one. We just got done talking about it. If there is no power, it is going to be constant. Constant. Alright. If it is going to be x plus 4, that would be linear. Okay. If it is going to be the second power, that is going to be quadratic. Kind of like the quadratic formula. Usually when you have a power, x to the second is when you use the quadratic formula. So that is going to be quadratic. Cubic is going to be to the third power. Just like when we have something cubed. Or, yeah, basically that. Alright, what about 4? Well, that is going to be quartic. Think of quartz. Quartic. And 5 is going to be quintic. That one's probably pretty new to you. Okay, so that one's all gone. Linear's gone. Quartic's gone. Cubic's gone. Quadratic's gone. That is when you name it based off of using the degrees. This is kind of important. Obviously, on your quiz and test, there's probably going to be a couple that you have to put or do this with. Alright, so now we have to do it by naming using the number of terms. So there's only one term here. So this is going to be a monomial. Alright, this one is going to be, well, there's two terms. So binomial, bi meaning 2, would be the answer. Alright. And then the next one is going to be monomial again. Or monomial, whatever you want to call it. Alright, then you have 1, 2, 3 terms here. 3, trinomial. Alright, then you're going to have 1, 2. That is going to be a binomial again. Alright, and then you're going to have have 4 terms here. Anything that's over 3, they're probably going to call it a polynomial of, in this case, 4 terms. If it's larger, it would be the number of terms. Okay? That chart is going to be very helpful to you at times. Okay? Definitely on your homework. Alright. We have to write each polynomial in standard form. What is the classification of each polynomial? By its degree, and by its term. We have to go descending order based off of exponents, so we're going to get 5x to the 4th plus 3x to the 3rd minus x. Okay? It's to the 4th, so we are going to have quartic. Alright, there's 3, so it's going to be trinomial. Yeah, and that's all you have to do. Probably worth 3 points on your homework. Alright, now we have negative 4x to the 5th plus 2x to the 2nd. These two are both constants, so we have to add them together. We get 13. Alright, we have to the 5th, which is quintic. Alright, and it is going to be 3, so it is a trinomial. So far, I'm guessing you're thinking this lesson is not too bad. Okay. Alright, polynomial functions. This is the whole point of this section. We will get into this. These are just some examples. We have y equals 4x to the 3rd minus 3x. And behaviors up and up. And we will talk about that on the next slide. Turning points. So we have a turning point. We came down and then we're going to go up. So there's a turning point. We had one here. Basically right here, it turned and went the other way. Got here, it turned and went down, and then went up. We have 3 turning points. This right here, this exponent, tells you the max. Now, not that I want to look at these too much, but this one's to the 3rd too, Mr. Riedel, and it says ending behavior, or 0 turning points. It says max. It does not say there's a minimum. That just means at most there's going to be 3. There can be less. Just like over here, there's only 2 turning points, and it's to the 3rd. Okay? But it tells you that at most you can have that. Alright, the function decreases when x is less than negative 1.07. So it would be everything from here. Or it's going down here, so everything here is decreasing. Alright? The other spot it is decreasing is when x is greater than 0.0, so it'd be right here. Okay? And let's see. And that's kind of the point in which it's between these 2 points. So, in this portion right here. Alright, it is increasing right here and here. And that's what they're classifying. This is this first part right here. And the second one is it's just got to be greater than 0.22. Okay, so kind of describe that one really thoroughly. Everything will pretty well be the same. We are x to the 2nd plus 2x. We have worked with these. They're called parabolas. Alright, you're going to only have 1 turning point, which was our vertex. The function is increasing when x is less than 1 and decreasing when x is greater than 1. So, not a whole lot to explain there. This one you never actually turn. Okay? Your end behavior is up, down, turning points. There's 0 of them. You never really do. So the function is always increasing. Okay? And then this one is kind of very similar to this one, but just a little bit different because you don't have 3 turning points. Okay? Yeah, this up or the ending behavior. We're going to talk about that here. Okay. Positive A, meaning the number in front of your highest term. This number, if it is positive, and this is even, so if it's 2, 4, 6, 8, and so on, it'll be up, up. If this is still positive, but this is even, you're going to be down and up. Okay? When I think of positive, if you're up in the positive, you're going to have to come down to the negative. So it's got to be down right away. Then it's odd, so it's going to go, you know that you have to have either down up or up down. So you just got to remember if it is positive, you're going to go down first. Okay? Now, if it is negative, so there's a negative number out here, A is, then if this is even, it's going to be both down and down. Alright? If it is up and down, this must have been odd and this was still negative. Okay? That you should be able to do without even having to graph it. Okay? So you should be able to tell me that and probably how many turning points there at maximum can be. Probably not exactly how many, but you can probably tell me MX. So, considering the leading term of each polynomial, what is the end behavior? So we have, on this first one, we have a positive, and it is odd, which means positive, got to go down and up, because it is odd. This one we're negative, and we're odd, so we're going to have to be up and down. Okay? Like I said, you should be able to do that without even having to throw it into a graph. Okay? What is the graph of each cubic function? Describe the graph. So describing the graph is exactly what that chart did before. So I'm going to have to end up writing this, or putting this into my computer, into Desmos, and while we're at it, why don't we write down here y equals x to the third minus 1. Okay? It is negative, it is odd, so that tells me the end behaviors is probably up and down. End behaviors on this one, it is positive and it is odd. So that means it should probably be down and up. Okay? Obviously, both of them to the third power, so at max, I can have 3 turning points. So, this is what I get. Okay, we're coming down. I would say probably right here is a turning point, and probably right here is a turning point. So, turning points. We have 2 of them here. So, turning points in this one. Turning points. This is why you're going to have to use decimals, because of the fact you are not going to be accurate enough. So 1 is going to be at about 1/3, parentheses, negative 2.148. Alright, and my other one's going to be at 1, negative 2. Okay? So there's my turning point. Increasing and decreasing. Okay? We're decreasing right off the bat, so when x is less than 1/3, it is going to be decreasing. Okay, then we're going to increase after that. So increasing when x is greater than 1/3, but less than 1. Okay, decreasing is going to be when x is greater than 1. Those are going to be your times that you're increasing and decreasing. I'm done with that. I described it with everything I could on that one. So now we have this other one. We have y equals x to the 3rd plus 1. Not minus 1. Alright, so we have this. We have no turning points here. So turning points are going to be 0. Turning points. None. Okay. Increasing, decreasing. The function is always increasing. Okay, check my end behavior. We're down at the beginning and we end up. Did a good job describing. Yeah, done at that point. Okay, we have one last thing to do here. Okay, we can tell what type of degree it is based off this chart over here. Okay, right here we have a difference of -6 plus 4. Must be 8 at adding. Alright, 6 minus 2. Probably minus 16. Okay, found that none of these are, these all have to be the same. None of them are. So we know it's at least the first degree. Okay, goes again. Probably going to be at least the second. Right now we got a difference of 10. Got a difference of 4. Difference of -2. Difference of -8. Difference of -14. Okay. Make sure you can see that. That's 10. So degree of 2. We're probably going to be at least 3 degrees. This is going to be 6, -6, -6, -6, -6. This one is going to be a degree of 3. Or also, you could call it cubic. Yeah. All you have to do is you got to keep finding the difference until they're all the same. Every time that you have to do it again is another degree. There is your homework.